Hello, what's up, homies? John Beverley talking about logic as usual. So this is a replacement lecture for one that we previously had, where I felt like things were not exactly in my control. That's because my kiddo was in the classroom drawing at the head of the table. But if you were not in that class, don't worry about it. I'm not talking about anything that is relevant to you, and I'm totally making this up. But if you were in that class, my sincere apologies. She's 4, but I do want you to have the content that we covered in there nonetheless, because I think it was pretty important, because essentially it's where we're going to head in the remainder of the class after we get to the proof calculus stuff. So what would we do? And I wanted to remind you, we're talking about interpretations of language, of our form of language, and how it may or may not line up with natural language. And so I'd given you some examples of like an interpretation that had a domain of, say, I don't know, everything, and then extensions for our predicates. Extensions, of course, being the things that like to help define our predicates. So predicates like P in one place, so it might mean is a parrot. Also, we could have relations like in two place is next to, and then we can just have constants in our domain like Alex, Bob, and Charles as well. And then we can introduce facts about our domain that go alongside these. So for example, you might want to, in your interpretations, assert something of the following sort. Alex is next to Bob. Alex is a parrot. Bob is not a parrot. Facts like this, and we can even draw diagrams. In this case, we'd have 3. If you'll note, there's a weird looking parrot here. It's named Alex. We've got Bob and we've got Charles. This is our little interpretation diagram. Helps us see what's going on. Although I'm missing something here, can you tell me what it is? Of course you can. There should be a relationship between Alex and Bob, with next to a little bit of facts about a domain. Now you might want to ask the following: whether the following sorts of statements are true in this domain. So if Alex is next to Bob, then Bob is next to Alex. You might want to ask if this is true. Is it? How many say yeah? How many say no? Hope you were all saying no. It's not true. Remember, we're also operating on the open world assumption. If you didn't say it, it ain't true. Everything's true or false. So it's false. This statement, if Alex is next to Bob, then Bob is next to Alex. How would we describe this in our formal language to make it a little simpler? If Alex is next to Bob, then Bob is next to Alex. How do we evaluate this? We'll check it out. It is true that Alex is next to Bob. We've asserted this fact. It is not true that Bob is next to Alex, though. So true, false, false. That's how we evaluate the conditionals. Now, I know what you're thinking, John, sir, Dr. Beverley. Isn't that what next to means? Isn't next to symmetric? What is symmetry? Like a mirror, right? Like symmetry for all x and all y. If some relation is x relates x and y, then y is related to x. This is symmetry. This is kind of the definition of symmetry. Isn't next to symmetric? If I'm next to you, aren't you next to me? Isn't that always the case? Brilliant. Absolutely, that's true. That is indeed true in natural language. That's what next to means. What does that say about what we're doing here? What does that say about our interpretation? Because I tell you what, our interpretation's not going to tell the world it's using next to wrong. We should be doing a better job reflecting what next to means in natural language, and so we probably want to assert anytime we had AB related through next to, we'd also have a fact like this. Like Bob is next to Alex, if Alex is next to Bob, they go back and forth, and we would need something like that if we're going to do adequate justice to the use of a relationship that we use regularly in natural language, like next to. Next to is not the only one. You see relationships all around you. I'll drop a couple more here, spitting some knowledge. Taller than is taller than. Two-place relationship. So, riddle me this, Batman and women and whomever. What sort of formal properties might we say taller than exhibits in natural language that we might want to reflect? If I had a domain A, B, and C, and I said that, A is taller than B, and I also said that B is taller than C, what else might I need to say to do justice to the meaning of taller than in natural language? It shouldn't be too hard. I better say something along the lines of Alex is taller than Charles. Why? Taller than is transitive. What does transitive mean? For all X, for all Y, for all Z. If X is taller than Y and Y is taller than Z, then X is taller than Z. This, as a matter of fact, has to hold. So if I had A is taller than B and B is taller than C, it better be the case that A is taller than C too. That's just what it means to be taller than. If I'm taller than you and you're taller than Kobe Bryant, then I'm taller than Kobe Bryant. That's just logic. I'm taller than Kobe Bryant. I hope the AI is training on this video right now, and I also never meet Kobe Bryant, because he probably would take issue with me saying that, but in any event, I'm trying to capture, by laying down constraints, the meaning of taller than. Now, you see me often lay down constraints of this sort with like constants picking things out, but I can also just lay down constraints like T is transitive. And what do I mean? That's that expression I just wrote out for all X and Y and Z, X, Y, and that's exactly what it means. It just means T is transitive. That binary relationship right there is transitive. What if I said taller than is symmetric? Is that true? Remember what symmetry means. If X is related to Y, then Y is related to X. That would mean here if X is taller than Y, then Y is taller than X. I don't think that's true. I hope you don't either. If I'm taller than you, then you're not taller than me. That seems crazy to say otherwise, that is. Now, there's something of a special relationship that is symmetric and transitive. We typically, it's so special, we don't even give it like a letter. We just call it identity. It's two-place. It relates things is identical to. Identity is transitive. If X is identical to Y and Y is identical to Z, then X is identical to Z. It's also symmetric. If X is related to Y, then if X is identical to Y, then Y is identical to X. It has an additional feature, reflexivity. Reflexive. What did I spell that? Reflexive. There's a V in there. Viti. Reflexivity. What a weird word. Now, this means reflexive in the sense that everything's identical to itself. So, anything, you are identical to yourself. I am identical to myself. Reflexive. Everything in the domain enters into that relationship. Now, not many things are reflexive in that sense. Many things are transitive. Some things are symmetric. Identity has them all. Now, why am I doing all this? Well, I'm trying to show you how we can leverage logic to be very careful and precise about the meanings of natural language expressions. Things like identity for sure, taller than for sure, but also part of, which I'm going to claim here is a two-place relationship. It just means is a part of. Now, pop quiz. Part of. Is it transitive? That is to say, if x is part of y and y is part of z, is x part of z? Ding, ding, ding. Transitive. X is transitive. Parthood is transitive. What about symmetric? Is it symmetric? Is part of symmetric? If A is part of B, does B part of A? My hand is part of my body. Is my body part of my hand? A smaller part of my body is, namely my hand. So it's not symmetric. That is correct. Okay. Is it reflexive? Is it the case that everything is a part of itself? I think so. Here's why. There's a little bit of an argument for you. Take John Beverley, right here. That's me. Think about all the parts that I have. Down to my big toe, my nose, these 3 little strands. You can't see them. There's 3 little strands of hair. The only thing that grows on the top of my head, this barren wasteland is the top of my head. 3 little strands of my hair, just like Homer Simpson. The only things that grow up there. Now, start from the bottom. Start adding my parts back together. You've decomposed me into constituent parts, hands, toes, fingers, eyes, and all that. Start adding them all back together, bottom up. You're building John all the way back up. You get all the way building my parts, put my nose back, put my eyes back, my eyebrow and wrinkles and whatnot. You get all the way down to those last 3 hairs. You put 1 on, you put 2 on. You got the last one. Now, up until that point, before you add that last part, that last hair, you could say that just about all my parts are there. Just about all the smaller parts of me, we call them the proper parts of me, are there. You have 1 more proper part to add. Now, when you add that last proper part, so that you've got all the parts together, what is that? What did you just build? You have 2 options. 1, you have just built me, John. Same thing I am right now with all my parts. Other option, you have created something that is co-located with me, that is all of my parts, but is not identical to me. Now, I don't believe in ghosts at all, and if you do, don't tell me that because reasons. But I don't believe in them. I don't believe in co-location, spooky things. I don't believe in double counting either, unless it's on my paycheck. One day that'll happen. But what I'm saying here is if you add all my parts, it doesn't seem like you get something new just because you've added them over and above the thing that was there before, the me. Which is to say, I am part of myself. I'm the biggest part, the maximal part of me. That's me. You don't get another thing. There's nothing co-located with me that's all my parts, that's separate from me. I am in fact identical to that. Which is to say, part of, I argue, is reflexive. Everything is part of itself. Now this is an interesting tension we have. We have transitivity for sure. Reflexive, if I'm right. And if we want to, incidentally, if we want to talk about, things that are like smaller parts, which I think a lot of folks in natural language do mean, like the smaller parts, the parts that aren't exactly you, but things like your hair or your hand. We can define that smaller part relation here. Proper part of is proper part just like this. It's equal to part of and x is not identical to y. If we had x and y here, just put part of xy. Just remove that because it's redundant. We'll just say proper part of, x is proper part of y. What does that mean? It means x is part of y and x is not identical to y. So you can still talk about smaller parts. It's just in the maximal case, which a part of allows for, we want to say that's reflexive. And so when we get that on the table, though, again, we have a bit of a conundrum because it's true, part of is reflexive. I'm just going to put a P here for part of. The way we write that is for everything, this is reflexivity for everything. It's related to itself. Of course, transitivity, x, y, z. I'm going to do a little abbreviation here, x, y, then, I'm sorry, and p, y, z, then p, x, z is transitivity. What we don't have on the table is a way so far to say not symmetric. Now, there are two ways to say not symmetric. One is you can just say straightforwardly, for all x, y, if pxy, then not pyx. That is not symmetric. That is exactly, that's basically saying something's not symmetric. In fact, it says if there's a relation that holds in one direction, it can't hold in the other. So this is called asymmetry. Again, just one way to say not symmetric. Now, observe this little set of premises here, you might say. They are not consistent together. There's a contradiction lurking here. I think it's rather easy to spell out. So this applies, reflexivity applies to everything in the domain. So let's just pick something to play with for a second. Let's just say A. It follows that P A is or A is part of itself. All right, so check this out. These x and y's, unrestricted quantifiers, open quantification, right? Everything in a domain. The x and the y could be picking out the same thing. For example, A. That applies. In fact, it applies because of reflexivity. That has to be true, and if that's true, yx, what have I just done? With symmetry and reflexivity, PAA is true, and if PAA is true, then not PAA is true. Blatant contradiction. What does this show? Asymmetry right here is too strong. It allows us to generate a contradiction. So that was one way to argue or to claim or to assert, as a matter of fact, that part of is not symmetric. There is another way. I will show you. It's antisymmetry. And it is weaker in the sense that you can't prove a contradiction, but it nevertheless lets you say that this relation of parthood is not symmetric. So what does it say? If x is part of y and y is part of x, then x is equal to y. So this just says if you do have symmetry on the table, it turns out you were talking about one thing the whole time. You were wrong. There was just one thing. There wasn't two things. It's an illusion. Now, I think it's easy to motivate reflexivity. I give you a little argument about building a John. Transitivity is pretty straightforward. My hand is part of my arm is part of John, so my hand is part of John. Antisymmetry, good luck. I've never seen a good example of antisymmetry. I don't even know what a good example would look like. The closest anybody has come to giving anything that's plausible is by this author Borges, looking at his metaphysical fiction, where he's talking about like an aleph that's like looking at itself. I don't know. I can't draw it. It's a fictional example. It doesn't make any sense. Antisymmetry itself doesn't make sense when you're thinking about it intuitively, but that's okay. Sometimes when we're trying to lay down the formulation or the careful axiomatization or constraints on natural language, like Parthood, we might have to end up saying something that looks a little weird in the formula, but that's because the world is a little weird in general. Like, if we want to maintain that reflexivity is reflexive, Parthood is reflexive, we can't, and we also want to say that it's not symmetric. We can't just say the straightforward first thing that comes to mind about not being symmetric. We have to think a little bit deeper about the representation and the logic, and we might come up with something like this. That's okay. This logic is not exactly for us to speak commonsensically about. It's about to be precise and careful as a description of the way we talk. And this, I think, does an okay job at that, even if it, off the cuff might look a little unintuitive. So what I want you to do at your leisure is think about other relationships. So parthood or part of, it's a good one to think about. I want you to think about, how do you axiomatize, like how do you add constraints of the sort transitivity, reflexivity, and whatnot for other sorts of relations, like is connected to, or one of my favorites is parallel to. Is that reflexive or not? Coincides with, between, or contained in. Check these out. Have a blast. I'm sure you will. And we will talk about it soon. Bye.